Alright, I just got my textbook after like 3 weeks of waiting, so I figured it'd be fun to do one basic example here just to break out this bad boy. So we got its Introduction to Linear Algebra International Edition. I'll put it in the description. So let's just start with number 1. So what they're asking is determine whether it is linearly independent or not. So they give some vectors in the book. I'll just tell you what they are. So this is v1 and v2 is equal to that. So pretty much all you have to do to find out if they're linear independent is to stick them into one big matrix where v1 goes here, v2 goes here, and then we solve this like pretty much any other matrix. We put it in reduced row echelon form. I mean, there's multiple ways you can solve it, but that's the way they typically ask for. So let's start. Obviously you can do row operations, so we're going to call this row 1, row 2, so we can subtract 2. You can also multiply by scalar values and just a constant, just a number. So let's see. So we're going to subtract, so it's as if we're taking 2 minus 2, which is this. This is the square part, this is the circle part. So obviously that's going to be 0, because reduced row echelon form is defined as whenever there's a 1 appearing in the column, everything else should be 0, as long as it's the first row, first column where it appears. So we want to make like the stair-stepping function. So we're almost done now because it's a really small function. So let's put this 1 back there. And then we also have 3 minus 2 times 2. It's going to be -1. So as I said before, we can multiply by a scalar value. So let me just erase this. Oh, the flow is not on. There we go. Alright, so an easy way to do this is we're going to do -R2. So the only thing that's going to change is this is going to become positive, make it a little bit easier to maintain. So we almost have in the form we want. So we have the staircase. This row's good, but this, as you can see, it's not the only non-zero 1 in the row. So we're going to have to subtract from R1 to R2's, which is going to give us 1, 0, 1, which means x1 equals 0, x2 equals 0. If you don't know where that came from, you could also call it like x and y. So let's say it's x equals 0, y equals 0. So each column is just a variable. And there are other videos out there explaining how matrices work, but at a basic level this is it. And since they're equal to 0 and none of them rely on each other, that means they're linearly independent. So they're independent. And if it ended up being like x equals y, obviously they depend on one another because the value directly affects the other one. And that's all.